Students, in this session, I'm going to explain you about the Michaelis-Menten equation. In 1903, Victor Henry, while working with the enzyme catalyzed reaction, proposed a concept that enzyme molecules, whenever react with the substrate molecules, form an enzyme substrate complex, and eventually this complex lead to the formation of the product and free enzyme. So in 1913, later in 1913, this concept was expanded into a general theory of the enzyme action by the Michaelis, by Leonard Michaelis and Maud Menten. This resulted in the derivation of an equation, and that equation is nothing but that equation is called Michaelis-Menten equation. According to this Michaelis-Menten equation is the simplest equation which explains the kinetics of enzyme catalyzed reaction. Secondly, from this equation we can we can derive we can or from this equation. This equation actually states us the relationship between the rate of an enzyme catalyzed reaction and substrate. Now let us derive this equation. Consider the reaction. Consider just consider an enzyme molecule is going to react with a substrate molecule to produce enzyme substrate complex, and this enzyme substrate complex is going to form the enzyme and product. Now let us consider the rate constants. Let the rate constant of the formation of the ES complex be K1 and its reverse reaction. Breakdown of ES complex to enzyme and substrate complex be K minus 1. At the same time, this ES complex breaks down to produce enzyme and product, and let us consider its rate constant as K2. Okay, let us consider its rate constant as K2. And now we will consider this equation. Let this equation be equation number 1. Okay, the formation of the product from the enzyme substrate complex. The formation of this product from the enzyme substrate complex is purely a first order reaction. Therefore, this V is equal to the formation of the product. Formation of the product is equal to is the first order reaction, and therefore it is equal to K2 into ES. Therefore, we can say that V is equal to K2 into the concentration of the enzyme substrate complex Therefore, let us consider this V is equal to K2 into this ES complex, and we will consider this equation as the second equation. Okay, so the formation let us consider this equation as the second equation. Okay, there the overall rate of the formation of the ES complex. The overall rate of the formation of ES complex mainly is actually the difference between the formation of ES complex and its disappearance. I am repeating, overall rate of the production of ES complex is the actual difference between the rate of the formation of the ES complex and rate of its disappearance. So now we will know the formation of the ES complex. The formation of ES complex is equal to, it is equal to K1 into S. The concentration of the E. See, if we look at the equation first, the formation of the ES is going to be formed from the enzyme and substrate molecules. Therefore, the formation of the ES complex is equal to K1 into enzyme into the substrate molecule. K1 into E into substrate. Okay. Now we will consider the breakdown or disappearance. The disappearance of the ES complex is equal to, yes, K minus 1 into ES complex plus K2 into ES complex. So I am repeating, the production of the or the rate of the production of ES complex at any time, at any given time, mainly depends on the difference between the formation of the ES complex and its disappearance. So therefore, accordingly, the formation of the ES complex. So the rate of the formation of ES complex, that is D into formation of the ES complex is equal to the rate of the formation difference in the formation and disappearance. ಒಂದು ಡಿಫರೆನ್ಸ್ ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ, ನಾವು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಸೊ ಫಾರ್ಮೇಶನ್ ಆಫ್ ದಿ ES ಗೆ ಏನಂತ ಹೇಳ್ತೀವಿ, ಫಾರ್ಮೇಶನ್ ಆಫ್ ದಿ ES ಗೆ ಈಕ್ವೇಶನ್ ಏನು, K1 ಇಂಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ E ಇಂಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ S. ಡಿಫರೆನ್ಸ್ ಅಂದ್ರೆ ಮೈನಸ್ ದ ಡಿಸಪಿಯರೆನ್ಸ್ ಅಂದ್ರೆ ಇದನ್ನ ನಾವು ಏನ್ ಮಾಡ್ಬೋದು, K ಆಫ್ minus 1 into ES complex plus K2 into ES complex. ನೋಡ್ರಿ, ಮೈನಸ್ ಇದನ್ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ದಿಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು K1 into concentration of the E into concentration of the S minus K minus 1 into ES minus S. K2 into concentration of the ES. This is actually, we will call this as an equation 2. Let us call this as an equation, this is an equation 3. This is the equation 3. See? So this is overall the rate of the production of the enzyme substrate complex is actually the difference between the formation of the ES complex and the disappearance or breakdown of the ES complex. So according to, we are deriving this equation according to the steady state assumption. Okay. According to the steady state assumption, to the steady state assumption, at any given time, the enzyme substrate the concentration of ES complex remains constant. It's steady. So therefore, according to this, we can say that the rate of the formation of the ES complex is exactly equal to its rate of the breakdown, and therefore at any given time ES remains constant. So therefore, according to this, what happens ಅಂತ ಹೇಳಿದ್ರೆ, this the formation of the ES complex is almost equal to its disappearance, and therefore this will become zero. D of ES by dt will become zero. So therefore, if we apply this to the third equation, so what is the equation T? Equation 3, that is d of Es by dt is equal to this one. This entire thing is equal to 0. So therefore, what is des by dt? This des by dt is nothing but the K1 into enzyme concentration into substrate concentration minus K minus 1 of ES complex minus of K2 into ES complex is equal to 0. Okay. So, if we simplify this one, we are going to have K1 into E into S is equal to K of minus 1 into ES plus K2 into ES. So therefore, ಇಲ್ಲಿ ನಾವು enzyme substrate complex ಅನ್ನ common ತೆಗೆದ್ರೆ, if we have taken the common factor as ES complex, K of minus 1 plus K2. So therefore, here it will be K1 as usual. E into S. Okay. Therefore, E into S by ES complex is equal to K of minus 1 by K2 by K1. So look at this. RHS of the equation. This is all the things here are constants. So this is these are all the constants, and all these constants together are called as Michaelis Menten constant, and that is equal to, that is therefore K of minus 1 plus K2 by K1. It's this entire thing is a constant, and together all these constants together was called as Km. ನೋಡಿ, ಕೆಲವು ಬುಕ್ಸ್ ಅಲ್ಲಿ KM ಅನ್ನ ಕ್ಯಾಪಿಟಲ್ K ಕ್ಯಾಪಿಟಲ್ M ಅಂತ ಬರೆದಿರ್ತಾರೆ. ಇನ್ನು ಕೆಲವು ಬುಕ್ಸ್ ಅಲ್ಲಿ ಇಟ್ ಇಸ್ ಕ್ಯಾಪಿಟಲ್ A ಕ್ಯಾಪಿಟಲ್ K ಅಂಡ್ ಸ್ಮಾಲ್ m, ಬೋತ್ ವಿಲ್ ಡೂ. ಓಕೆ, ಎರಡೂ ನಡೆಯುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ ನಾವೇನಂತ ಹೇಳ್ಬೋದು ಅಂತ ಹೇಳಿದ್ರೆ, ದಿಸ್ E ಇಂಟು S whole divided by this ES complex is equal to one constant, and that constant is nothing but the Michaelis Menten constant. Here the Km is nothing but the Michaelis Menten constant. We will discuss about this Km later. This Km is called as Michaelis. It is called as Michaelis Menten constant. Okay. So, okay, we will call this above equation, this equation as equation number 4. Okay, we will call that above equation as equation number 4. Okay. Now we will consider. So till now I have explained that this E is nothing but the concentration of the free enzyme, and ES is nothing but the enzyme substrate complex. And both these components can't be measured experimentally. ಈ ಎರಡು both these concepts can't be measured experimentally, and therefore um, but we can measure this total enzyme very accurately, the total enzyme that is participating in that reaction very accurately. So therefore we are going to introduce one more concept, that is the total enzyme. The concentration of the total enzyme is equal to the concentration of the free enzyme plus the concentration of the enzyme substrate complex. So accordingly, the concentration of the enzyme substrate complex is equal to, it becomes the concentration of the total enzyme minus the, sorry, ಇದೇನಾಗಬೇಕಿತ್ತು, the concentration of total enzyme, the concentration of free enzyme. Okay, because we can't able to measure this concentration of free enzyme, so concentration of free enzyme is equal to the concentration of the total enzyme minus concentration of the enzyme substrate complex. Let us consider this as an equation number 5. Idana, we will consider this as an equation 5. So if we substitute equation 5 in equation 4, if we substitute this equation 5 in equation 4, equation 4 is nothing but we will, let us call this as this, we will call this as an equation 5. Okay, let us call this as an equation 6. If we substitute this equation 6 in equation 5, equation 5 is nothing but the, this equation 5 is this one, con E into S by ES is equal to Km. Okay, if we substitute this value, the free enzyme is nothing but the concentration of the total enzyme minus the concentration of the ES complex divided by, sorry, into S divided by this ES complex, and which is equal to Km, which is equal to Km. Therefore, Et into substrate concentration minus ES into substrate concentration this whole divided by the ES complex is equal to Km. Therefore, Km into ES, or therefore therefore this ET into the concentration of the substrate minus ES into concentration of the substrate will be equal to Km into ES. So let us shift this value to this side. Therefore, the ET into concentration of the substrate is equal to Km is equal to Km into ES plus ES into substrate concentration. Okay, here look here, we can take out the ES as common factor. ES can be taken as common factor, and therefore if we have taken ES as the Km a common factor, it will become ES into Km plus S. Therefore, the total enzyme concentration into substrate concentration is equal to ES into Km plus S, and therefore finally enzyme substrate concentration is equal to ES is equal to ET into substrate concentration by Km plus S. Km plus S. And let us call this equation as six. Let us call this equation as equation number 7. We will call this equation as equation number 7. So now now consider the second equation. Equation number 2 is nothing but the, consider second equation. Equation number 2 is nothing but the K2 into V, rate of any enzyme catalyzed reaction, is nothing but the K2 into ES. So if we substitute this equation 7 in equation 2, if we substitute equation 2, sorry, equation 7 in equation 2, we are going to have V is equal to K2 into ES. ES is nothing but the concentration of total enzyme into concentration of the substrate whole divided by Km plus S. Okay, now let us understand the concept. When all the enzymes, okay, see, when all the ET is nothing indicates the total enzyme. So when all the enzyme molecules are saturated with the substrate, or when our active site of all the enzyme molecules, if they are going to be bound by the substrate molecules, then the maximum velocity is reached. So this happens at high concentration of the substrate. So whenever there is a sufficient substrate, or whenever there is a high concentration of the substrate molecules, whatever the enzymes are there, whatever the enzyme molecules are there, they are all going to be saturated by the substrate molecules, and therefore the velocity of the reaction is going to be maximum. So thus this K2 into T, if all the enzyme molecules are going to be occupied by the substrate, then this K2 into T is definitely going to be a maximum velocity. See, according to the equation 2, what happens? V is nothing but the K2 into ES. Just imagine, if all the enzyme, total enzyme, if all the enzyme molecules are in ES complex, then V will be the maximum. Velocity will be the maximum. So therefore, if we apply the same concept here, so then what happens? This V is equal to this K2 into T is nothing but the, if all the enzyme molecules are in ES complex. Therefore, this K2 into T is nothing but the V max. And S is the, as usual, the substrate concentration, and this is Km by the concentration of the substrate. So now this equation is called as, Michaelis-Menten equation. Okay, this whole equation is called as Michaelis-Menten equation. So this Michaelis-Menten equation is nothing but the, ಏನಂತ ಹೇಳ್ತೀವಿ, V is equal to Vmax into S by Km plus S. I'm summarizing the session. Once again, I'm summarizing the session. Okay, I'm summarizing the session. So initially, let us assume that if the enzyme molecule, whenever the enzyme molecule reacts with the substrate, it's going to form an ES complex, and eventually it breaks down to enzyme and product. And let us consider this as equation number 1. So the formation of the product mainly depends on the concentration of the ES, and it's a first order reaction. Therefore, if we write the first order reaction, V is equal to, it's definitely equal to K2 into ES. So therefore, V is equal to, we can say that K2 into ES, and let us consider this as equation number 2. At any given time, the total the rate of total production of the ES complex mainly depends, is actually the difference between the formation of the ES complex and its disappearance. So the formation of the ES complex is represented as K1 into E into S, and the disappearance is represented by this equation. So therefore we can say that the rate of the formation of the ES complex, or production of ES, at a rate of production of ES complex at any given instant, is therefore the difference between the formation and disappearance, and this is the equation we are going to have. And if we, okay, and this is the equation, and this is the equation 3, and let us call this as equation 3. So according to the steady state assumption, we are deriving this Michaelis-Menten equation according to steady state assumption. According to the steady state assumption, at a given instant, at any given time, the overall concentration or concentration of ES will be constant. It means the rate of the formation of the ES is definitely equal to rate of its breakdown. Therefore, this one, the d into ES, d of ES by dt is always equal to 0. So according to this equation 3, then what will become, then this equation 3 will be is equal to 0. If we simplify it, we are going to have the equation 5. Okay. At the same time, if we consider the free enzyme and ES complex, we can't able to measure the even the free enzyme and ES complex, but we can measure the total enzyme. So therefore, we can say that this total enzyme, let the concentration of total enzyme be the free enzyme and ES complex. And if the concentration of the free enzyme will be definitely equal to ET minus ES, and let us call this as equation 6. So if we substitute this equation in the equation 5, we are going to this one. If we simplify it, finally we are going to have this equation 7. Okay, now if we substitute this equation 7 in the equation 2, we are going to have this equation, or we can call it as equation number, let us call this as equation number 8. In the equation number 8, and just compare equation number 2 and equation number 8. So in just here what happens is, if all the enzyme, just assume if all the enzyme molecules, if they are occupied by the substrate. If all the enzymes are saturated by the substrate molecule, then according to this equation, velocity would be the maximum. So therefore, V is equal to, then V is equal to V max into S by Km plus S, and this equation is called as Michaelis Menten equation. Shortly we call it as MM equation. Okay, so this is about the Michaelis Menten equation.